Good morning, everyone. I am Dr.P.Ezhumalai, Professor and Head, Department of Computer Science Engineering, R.M.D.E.C College. Today, we are going to see the theory of computation, Lecture 1. Part in Unit 1, Lecture 1, we are going to see. First topic is the finite automata. So, finite automata is an abstract machine of modern digital computer. It has a finite set of states, machine, an abstract machine. It has a 5 components, or it may be called as a 5 tuple. It has a set of states and rules for moving one state to another state, but it depends upon the applied input symbol. Basically, it is an abstract model of digital computer. The following figure shows the essential feature of general automation. This is a model finite automata example. So it has 5 components are there. So it is an input component, input 1 and 2, 3, like this, a number of inputs are there. One input you are applying to at a time. So it is a CPU. Finite automata control, every control is a part of this finite automata. It has a n number of states, Q1 to Qn. So output will be there, Q1, Q0, 1 to output 1 to output n. So every time what is the input you are giving to the finite automata, it processes that. After that it gives as whether this input is accepted or not accepted. It means yes or no output will get from the finite automata. The features of the finite automata, parts of the finite automata are listed here. Input part, output part, set of states of finite automata, state relation, one to another state relation, so output relation. These are the 5 components of the finite automata. So finite automata definition. The finite automata consists of the following formal definition. So 5 tuples. The first one is Q is the capital Q is the finite set of states. Summation is the set of input symbol. What the input symbol you are applying for this finite automata is supposed to given into summation. Here the Q is the initial starting state of the finite automata. Capital letter F is the set of final states. When starting state is there, means there should be a final state. The final state consists of the F capital letter F. Delta is the transition function. So one state to another state, how we are transmitting one to another, it shows the delta transmission. This is the formal definition of finite automata. So there are 2 types of finite automata is given as per the syllabus. One is called deterministic finite automata, which is called a DFA. The formal definition of the DFA is the 5 tuples. Q, capital letter Q, summation symbol, small letter q, capital letter F and delta. So capital letter Q is a set of states. How many states are there in this finite automata is given as a capital letter Q. So what are the input symbol we are giving in this finite automata is summation mentioned as a summation symbol. So small letter q is a starting state of the finite automata. So capital letter F is a set of final state. Say there is a possibility of more than one final state, so we call it as a set of final state. Transition function is defined as Q, the actual set of states, that is Q, one input symbol, one state followed by corresponding input symbol due to the next state. The Q is the next state. So Q into summation gives the next Q, next state. So example of DFA. The following diagram shows the example of DFA, which is a string accepted ending with 0. So what are the inputs? We are giving the input symbol 0 and 1. We are giving any input symbol 0 and 1 to the finite automata. So in this finite automata, so accepting all the inputs which contains 0 and 1, which is ending with 0. So it is a starting state. It's a circle with starting state indicated as arrow mark. So whatever the input is given 1 will be repeated for the state 0. So whatever the input is giving 0, we are going for next corresponding state, which is called state 1. After that, it follows any number of zeros. It will be circle for the self loop. We will go for the 1 to 1 circle. Suppose here the 1 is given in the Q1 state, again we goes for 0 state. So similarly, it repeated the 0 and 1 all the inputs, which is accepted if the input is ending with 1. This is a sample finite automata. The non-deterministic finite automata is following by similar for DFA. So except the powers are same, except the transition function. All the powers of the DFA and NFA both are same. So here the input symbol epsilon, empty input symbol is accepted in the non-deterministic finite automata. It can move forward without reading actual input symbol. So the ability to transmit to any number of states for a particular input. However, these above features do not add any power to NFA. If we compare both in the terms of power of both are equal, DFA and NFA, both powers are equivalent. Due to the above additional feature, the NFA has a different transition function. The rest of the things are similar for DFA. transition function Q followed into corresponding summation symbol followed by add with the epsilon symbol. The epsilon symbol is not allowed for a DFA. So in NFA we are allowing for epsilon symbol. So Q corresponding summation gives a 2 power Q. So there are n number of states, 2 power Q number of states transmitted. For example, they are giving 0, you can transmit 2 similar states, more than 1 states at a time. But DFA it can't like that. So one input symbol means only one output symbol will move. So in NFA, one input symbol, more than one output states can be more possible in the NFA. That is the only difference between DFA and NFA. So for example, NFA, you see that. So similar to DFA, they are giving set of input symbols 0 and 1. It's the starting state of the finite automata, non-deterministic finite automata. It is the ending state, final state. It's encircled by double circle. So all the inputs will be accepted with the ending with 0. So remaining, it is not ending with 0 means whatever the input is given, repeatedly self loop for this Q0 state. So it will not be go for final state. So when is accepted means when you reach the final state, we consider the input is accepted. This is a major difference between NFA and DFA. So I told that DFA contains Q is a set of states, summation is a set of inputs. The corresponding mapping of Q into summation gives only Q state for the DFA. But in the NFA, Q corresponding to mapping for the summation symbol, it goes for 2 power Q. Except this transition function, remaining powers are similar for both NFA and DFA. Thank you for this lesson. Thank you all.